Okay guys, today we'll be looking at science N4. So I have to thank this guy here who requested this question. So we'll be doing hydraulics. So on this textbook on our question here, it will be we'll be looking at question number 4 and 5. So I will just do question number 4 in this video, so I will do the question number 5 on the next video. So now the basic information that I want you to start by understanding is this. If we are having this hydraulic system here, this is a simple hydraulic system. So this hydraulic system, or this hydraulic press, this is a press. It has a lever system this side. So if we have this lever, this is the lever system. So this is our lever system. So this lever system, it has an effort here. So this effort is the force that we applied so that we can push this plunger, so we can lift this piston, this ram, this side, or our load on the ram. So what we do have here is that if we apply our effort here, so that means if we this is our effort, that means the force on the plunger, it becomes what? It becomes our effort, our load on the lever system. So here we have what we have at the force F, which is the force of the plunger. Then let's write it here. So this force F, it becomes what? It becomes our load on the lever system. So if we are given the mechanical advantage, we know the formula for mechanical advantage is equals to the load over our effort. Now, so if they say calculate the effort or the force that we have to applied in this lever system, maybe to lift this weight here, they say this is the weight or the force on the ram side. So therefore it becomes that this we have to start by finding the force applied on the plunger. So therefore we can calculate our effort. So the force on the plunger becomes our load, so therefore we can calculate our effort. So now if we are calculating this point, so we have to understand that this hydraulic system, it works okay, let's say at 100%, at 100%, this point or this pressure here in the hydraulic system is the same pressure. We can say the pressure on the plunger side will be equals to the pressure on the ram side. So this is what is happening here on if we have what we have a 100% efficiency. So if we have 100% efficiency, therefore we have what we have the pressure is equals to the ram, the pressure on the plunger is equals to the pressure on the ram. So by the pressure, we know that the force, or the formula for pressure, know the pressure is equals to force over area. So because we are having what we are having this force, okay, because the pressure on the plunger is the same as the pressure on the ram, so therefore the pressure on the plunger over the area of the plunger is equal to the force of what of the ram side over the force of the area of the ram. So this is the formula that says F is over D squared is equals to W over capital letter D. So because here we have area, so this we know that the formula of an area, the formula of the area is pi D squared all over 4. So because we have pi d, pi this side and pi this side, the pi will cancel and the 4 will cancel, so we remain with d squared because this one. But this only happens when if it's 100% efficiency. So Now, because we know that the formula of efficiency, is what is our output. Let's say now we are talking about pressure, not the power, so it will be our output pressure all over our input pressure multiplied by our 100%, so it should be 100. So now the output pressure, it will be the pressure on the plunger, and then sorry, on the ram. So the input pressure, it will be the pressure on the plunger this side. So you can cross multiply here and get on, and then say the efficiency is equals to efficiency multiplied by the pressure of what, of the plunger, let me say PL, is equals to the pressure of what, of the ram, if we have an efficiency. So that means the efficiency in the hydraulic system, it affected the side of the ram side, of the plunger side. So that means now the formula can become our efficiency multiplied by the force. We say this formula is force is equals to d squared equals to w over d squared. Now this one is when we have the efficiency on the plunger. So if we have an efficiency of the hydraulic fluid, or the hydraulic, or of the system, yeah. So now you can calculate what you call the pressure. So if you do understand this, therefore it won't be a problem solving our question here. So let's jump to our question here. I don't know if it's clear enough, but because I don't have time in the I don't have time in the day, so only have time at night. So this is what our question looks like. So I can try. Okay, yeah, then I think it's now clear enough. So they say here the diameter of the ram piston of a hydraulic jack is 120 millimeters. Then the plunger has a diameter of 30 millimeters, and the stroke is 60 millimeters. So the mechanical advantage of the lever is 12. Then they say calculate now the force that must be applied to the lever to lift a load of 2 megagrams if the efficiency is 80%. So now what we have to do is to calculate our force on the ram side first. So let's write our what you call, okay, let me change this one. Let's write our data. Okay, the first thing we can say our data. Now we are given the ram, the diameter of the ram. So they said capital letter D is 120 millimeters. So we are using meter. We divide this into meters. So it's 0.12 meters. And then we are given also the diameter of the plunger. The plunger diameter, the small letter D, is equals to 30 millimeters. So if it's 30 millimeters, that means it's going to be 0.03 meters. And then we are given the stroke. This stroke is the stroke length. So the stroke length is 60 millimeters. So this 60 millimeters is what, 0.06 meters. And then we are given the mechanical advantage of the system. Mechanical advantage is equals to 12. Yeah, okay, mechanical advantage doesn't have unit. And then we have this. Now they say calculate what the question here. They say we must calculate the force. If we check here our question, and this is our question, calculate the force that must be applied to the levers, to the lever to lift a load of this point. This is our load of 2 megagrams if the efficiency is 80%. So this is what is happening here. We have this weight is the weight. It will be the force on the ram side. So if the weight is the force on the ram side, they given us the weight as a mass. Yeah? So if it's the weight is given a mass of 2 megagram, start by changing this mass to kg, not mega. So to change into kg, we know that mega is 1 million. So if it's 1 million mega, and then grams is on the grams, 1 kilogram is equals to is equals to 1000, yeah, 1000 grams. So therefore this one will be 2000 kg. So this 2000 kg is at the mass. So we are using what you call the weight. Weight is equals to mass multiplied by gravity. Therefore it will be 2000 multiplied by 9.8, which is our gravity, and our answer, it will be let's say this one is 2000 times 9.8, so it's 19,600 Newton. So this is our force, so or is our weight, or the force on the ram side, right? So if we do have this force on the ram side, now we have to calculate what you call the force on the plunger. So if we do have the force on the plunger, therefore we go to calculate what our effort on the lever. So we say the force on the plunger becomes what becomes our load in the lever system. So because of the efficiency, now we're given the efficiency of 80%. So because of the efficiency, so I said if you are given an efficiency, the efficiency affects the formula on the ram side. So that means so on the plunger side, so that means it will be the efficiency multiplied by force divided by this one, and then it will be equals to the force under. So this efficiency is because of maybe there is some friction between between the surface of the press and the fluid inside. So that's why we have efficiency them. But if it's 100% efficiency, the 100% doesn't affect us. So therefore now to calculate our force, let me change it to this side. So we said in our formula we will use what the efficiency multiplied by force of the plunger divided by the diameter of the plunger is equals to the force on the ram divided by the diameter of the ram. So therefore we are looking for this diameter of this force. So we say that our efficiency, so we are given the efficiency of 80%. So this 80% we converted, we divided by 100, so therefore it will be 0.8. So always the efficiency should be divided by 100, so we don't it be a number, so it won't be a percent anymore. So it will be 0.8 multiplied by the force we are looking for divided by and then the diameter of the ram is 0.03. You should put square is equals to the force on the ram side. We said the force on the ram side is 19,600 Newton, so it will be 19,600 Newton divided by the diameter of the ram side, 1.2 square. Therefore now we solve for what? For F. So you cross multiply, then you divide by the answer them. So it will be 19,600 multiplied by 0.03 squared all over 0.12 0.12 squared multiplied by our efficiency. So I hope you do, or we all know how to make the subject of the formula. Or if you can't make this subject of the formula, just divide this first and then divide this and get the answer, then finally divide this one with this answer from this point. So you get that our force there. So we can calculate our force. Let's say our force is 19,600 multiplied by 0.03 squared, squared, all over 0.12 squared multiplied by 0.8. So we get our force as 1,531.25 Newton. So this is our force of the plunger side. So if this is the force on the plunger side, now we say that this force becomes what? Becomes the load on the lever. So we say mechanical advantage is equals to load over our effort. So our effort is equals to the load divided by the mechanical advantage. So therefore our load is 1,531.25 divided by our mechanical advantage is 12. Then divide by 12, we get our answer of the force is 127.60 Newton. This is our force or our effort. That this effort is the force that we have to apply on the plunger, on the lever. On the lever. So remember, a lever system is one of the host or host. If you still remember on N1, you said that host is a device that we use to lift a bigger load or a bigger force using a smaller force. So our smaller force here is our effort of 127.6 Newton. So this is the force on the or our effort on the lever system, so that we can lift this load. Okay, so hope you do understand this question. And now let's look at the next one. The next question here, they said we should calculate the number of strokes needed for the lever to lift the load by 180 meters. So now to calculate the number of strokes, okay, right, again now I have to explain this side again. So when we are calculating the number of stroke, so we said the pressure, if it's 100%, the pressure on the ram, on the plunger is equal to the pressure on the ram. Now we have what you can say the pressure or the volume on the ram side is equals to, okay, say on the ram is equals to the volume of the plunger, but now it depends on the number of stroke. That means if you do one stroke this side, you have what? A volume. The volume will be the same. So the volume here, it depends on the number of stroke. Now if you have the number of stroke okay, the stroke, and then if you increase the stroke, the volume increases this side or both side. So the volume on the ram, it depends on the volume on the plunger. And we know the formula to calculate the volume of a cylinder. Volume of a cylinder is r squared divided by 4 multiplied by a length or the height. So this is the height, and then it's equals to the plunger on the plunger side divided by 4 multiplied by, so the height this side on the plunger is the stroke length. This length from this point to this one is the stroke length, this stroke length. And then h now becomes the distance that the plunger will move upwards. So this distance, this will be our h. So now they have given us the force the distance, which is h. So okay, here we multiply by the number of strokes. So if this one is the same this one, therefore we have this formula: d squared multiplied by h is equals to d squared multiplied by stroke length multiplied by the number of stroke. So this is the formula. Okay, so and then this is the formula if we don't have okay, on the next question there are on the slip, if you tune into my next video after this one. Okay, so and then now to calculate our number of stroke after so after lifting the height of to 180 millimeters, so it will be equals to divided by 1002 meters is 0.8. So now the number of stroke is d squared multiplied by h is equals to d squared multiplied by l multiplied by n. So we're looking for this number of strokes. So that means the number of strokes is equals to diameter of the plunger on the ram multiplied by the distance moved by the ram, which is h, divided by the distance of the diameter of the plunger multiplied by the distance moved by the ram or by the plunger. By the plunger is the stroke length of the plunger. It's equals to, so the diameter of the ram is 0.12 squared multiplied by our height is 0.18 divided by our diameter of the ram is 0. Of the plunger, multiplied by our length 0.06. So it's equals to and then now we punch our calculator. It will be from our calculator 0.12 squared but multiplied by 0.18 divided by 0.003 squared. Put the bracket squared multiplied by 0.06. So our number of stroke is 48. So the number of stroke is 48 stroke. This is our answer. So for us to be able to lift this one, okay, so for us to be able to lift the height of the height of the ram side, or to lift our load to a height of 180 millimeters, we need this side 48 pumping stroke. So the stroke is the downwards, the upwards movement downwards. So that means 1, 2, 3 to move this side up to 810 or 180 meters. So we need 48 stroke. Okay, and then now on this case, now they say calculate again the last question. Now calculate the number of stroke needed to lift the load by 180 millimeters if there is a slip of 8%. So yeah, that's 8%. If there is a slip of 8%, so the number of stroke needed to lift the load by 180 millimeters if there is a slip of 8%. So lastly, it was the same height, but there wasn't a slip. So that means there was 100% slip. We don't have a slip at all. So that's why our we needed 48 now, but because of this slip. So the slip now affects us on the ram side. So because the ram is on the plunger side, because the plunger is the one that is putting what you call is putting the force, or is putting the pressure in this fluid. So if there is a slip, that means maybe if there is a leakage or a slip, if you're pressing this plunger, and then maybe there will be a slip of some fluid going upwards to this point. So if it's an 8%, so if it's 8%, that means out of what? Out of 100%, we are only losing what? We are only losing 8%. So therefore it gives us what? It gives us 92%. That means we are having what? 92% in the system now. So this slip will affect this side of the what you call of our pressure of our plunger. So we can multiply by our slip in this formula. So our slip is going to be, let's say, the slip percent, and let me just put S slip percent like this. So this is the slip that will affect us. So to calculate it now, it's this very same formula. Let me just repeat this one. The very same formula, just now we are affected by the slip. This is slip, let's say slip percent as percent. So the slip, slip is 8%. That means we are remaining with 0.998. Because there is a slip of 8, that means out of 100% we are left with 98%. So this 98 divided by 100 give us 0.89. So this 0.89, going to put it here, very same formula, but now we are multiplied by the slip. Yeah. So therefore let me just try, okay, this one multiply by our slip is 0.9. okay, this is 89. So our is 40. Oh yes, sorry, I made a mistake. 100 minus 109 minus 8 is 92. Sorry, not 98. 92, yes. So that means here you're going to multiply by your 92 in this point. So there's the same formula. We haven't changed the height that we were lifting, which is still 180 millimeters, which is 0.8 meters. So our pumping stroke now, it will give us, if we calculate, put just this 92 underneath, which is affecting only this point. So therefore our number of stroke is equals to 50, 50, 52. Now that means we have to count 52.173 or let's say 4 of strokes. So we can just convert it maybe to 52 strokes. Yeah, 2 strokes. So this is how we calculate it, guys. I hope man you have answered now to your questions. So I will do the next question on the next video. So tune into for the next one. Hope you like the video. Thank you.